Houston, can you tell when we got good high gain lock?
Stand by.
Doesn't appear here that we got a solid lock.
Roger, we made an error in the calculations, 10. We're estimating now 5-3 before a good solid lock on the main lobe.
Okay. Okay, Houston, there's solid lock on narrow beam wedge.
Roger, 10. We're reading you 5 by. Stand by and see if we confirm. Roger, we got a good lock
You ought
up.
to be getting a good picture.
Okay, we got a good lock up. Goldstone's configured, ready to go.
Okay, you ought to be looking at it now.
Roger.
Houston, how do you read on? Hello, Houston, Apollo 10, how do you read on Vox?
Reading you 5 by on Vox, 10.
Okay, I'll kind of narrate this, Charlie. I'm having kind of an odd angle to hold it out the window. Again, you can see the west coast of Africa, the Sahara Desert there, all in orange. You can see the Atlantic Ocean with the swirls of clouds over to the eastern part of Brazil. You can see the very weird cloud patterns that Gene described out over the northeastern part of the United States. Again, it looks like the North Pole and that whole area up around Canada is completely socked in.
Roger.
Again, the one thing that really is so amazing about as you look at the Earth is the amount of cloud cover that we have down there. Over the tropical rainforest in South America, just numerous small cumulus clouds.
Roger, can you describe the color as contrasted to, say, the Andes or the American desert?
Roger, the color of the tropical rainforest there is more of a greenish brown. It's a greenish brown versus a brown orange on the American desert and the Sahara desert.
Roger, can you pick out the Amazon? Roger, can you pick out the Amazon River?
No, I can't pick out the Amazon. I'm looking at it with my naked eye where Gene had the 28 power binocular. I do have the zoom on here, so you're seeing it a little bit bigger than we are on a standard vision. So the Earth, as you see it there, is bigger. And you can see the Terminator, or nighttime, has moved over most of Africa at this time and is starting to move over to Europe. It'll soon be nighttime in Spain, and also it's getting daylight over in Hawaii in there. The cloud patterns are utterly fantastic as we look out at it.
Roger, 10, we copy. How about up around the clouds I asked you about earlier, up around the Bering Strait? Is it daylight over there yet?
They're just starting to come into view, and when we have our program TV pass through Goldstone, we should be able to take a look at that cloud frontal situation. It was a beautiful swirl yesterday.
Roger.
But it's also amazing how some of the clouds look pure white, and the other ones look more of a brownish white, kind of a dirty white. Again, if you look, you can see by Mauritania going over to Brazil, the intertropical convergence zone is always pictured in our weather maps. It's just a straight line right around the Earth. It's really beautiful with occasional outcroppings of cumulus clouds.
Roger, where are the brownish clouds located? Over the deserts or just where, Tom?
Right now, the brownish clouds are over the tropical rainforest and the Atlantic Ocean.
Roger.
Tropical rainforest in Brazil.
Roger, copy.
And we're about to lose you out our window.
We'll stand by. Goldstone and Madrid were both recording the TV. Got good signals both places.
Okay.
We'll stand by till you come out through the hatch window.
Okay, as we say, adios. disappeared behind our hatch window now. We'll see you later.
Roger.
Got it. That box worked okay, I guess.
Hey, 10, Vox was perfect. And none of the words were clipped or anything. It's like talking to you in the same room. 10 is really great.
Okay, that's the first time I guess we've really used Vox, and it seemed to be okay up here, Charlie.
Roger, you're not clipped at all. It's we're real pleased with it here, 10.
Right.
10, yeah, Houston, we'll have you on the high gain for about another 8 minutes, over.
All right, dear, for coverage on the Earth at all now. You're completely out of view. John will be able to pick you up down in the optics.
Roger.
Houston, Apollo 10, over.
All right, go ahead, John.
Roger, in about another hour and a half, you ought to be right underneath us, and boy, it ought to be the most remarkable picture of the United States ever made. The whole North American continent just standing out. It's really, and there's not too much clouds for a change. It's open.
Well, great.
See right now from Florida.
Go ahead.
You can see Puerto Rico, Haiti, Jamaica, Cuba, Florida. The Bahamas are under cloud cover right now. But in general, the whole United States, except for the New England states, and a path cutting down through the middle of the United States are wide open. You can see the Great Lakes very well.
Good show. We'll be looking forward to your TV show live here in a couple hours, and we should be, as you say, about right underneath you, and ought to get a good view. Thanks a lot.
Roger. Mexico and the Yucatan Peninsula, and even some of the Central American. I can't see Panama. I can see parts of Venezuela, Colombia, and of course most of Brazil is wide open. Chile appears to be open along the coast down there. Peru and Bolivia are probably under scattered clouds today.
Right, you guys are giving us
sure
a great weather report.
You sure see a lot of the world from up here.
Yeah, like maybe all of it.
That's John Young giving that description.
Charlie, I've got it out my window now, and like John said, it's so remarkably clear. Lake Superior and Lake Michigan stand out very brightly. There's just a little patch of clouds on the Chicago-Milwaukee area, or else there's snow on the ground. I rather think it's probably clouds. But you can almost pick out states by the contour of the sea and the oceans and the lakes. And I can actually see the Mississippi, not see the river, but you can sort of see the Mississippi River Valley as it goes up on north from the Delta.
Is this through the monocular or naked eye, Gene?
That's through the monocular, Charlie.
Right. That sounds like a spectacular sight. Wish we'd have had a stowaway up there with you.
Well, you know, you almost did until I wrote it in the OCP to get Joe Engel out of here.
Yeah.
What's also very interesting is to watch the continents come out over the horizon as the world
turns more towards us as the U.S. continent turns more towards us. Roger, we copy. And I agree now with John. You can see practically that whole island chain all the way down to Trinidad. We copy. It's hard to believe we is really here. Yeah, you guys are a long way away. We got you out at about 170,000 miles, a little bit more than that right now. 170, okay. Right, you're still below, if the drawing's right there, you're still below the Earth-Moon plane, and be coming up at about 195,000. You'll be crossing through the plane and going a little above. Hey, we're trying to get some
Charlie, what?
Go ahead, John.
We're not much below it, right? We're pretty close.
Right, yeah, real close.
You can watch the Earth through the optics, plus or minus 57.5 degrees in the sextant. So if you pick it up in time, you follow it for over 100 degrees.
Houston, we'd like you to select Omni Bravo and manual on the high gain, over.
Roger.
This is Apollo Control at 50 hours 24 minutes. Apollo 10 is 168,353 nautical miles from Earth, traveling at a velocity of 3,538 feet per second. This is Apollo Control at 50 hours 26 minutes. As an indication of how well this passive thermal control mode is working, Apollo 10 has not had a thruster firing since an elapsed time of 29 hours 53 minutes.
Hello, Apollo 10, Houston, over.
Go ahead, Charlie.
All right, John, we're looking here ahead in a flight plan, and we'd like to give you your P27 update at 52:05 or thereabouts, and hopefully we won't have to kill the PTC for you to do the realignment. You did such a good job this morning, and we think we can continue on in the PTC and let you do the realigning. We can get our update to you also in PTC mode. And we're suggesting that since this thing's going so great, that we just keep it going. And for TV, that we get the TV also during PTC, since it seems to be working fine. And we'll have about, at the present roll rate, we'll probably have about 10 to 15 minutes coverage with the high gain, so we can get the whole live TV in and be partial exterior and partially interior. And if that's agreeable with you guys, that's the way we'd like to play it.
Okay, Charlie, but I remember we was going to do a trunnion gal here one of these days, and I guess today isn't the day.
Well,
You can't do that unless you stop the PTC, over.
Stand by. We'll see if that's worth stopping for. Hold on. Ten, while we're waiting for the answer from the experts on the trunnion cow, we'd like you to turn to the back of your flight plan to the mission rule summary, and I'd like to talk about a few updates that we feel are are justified at this time, over.
Okay, we're turning to them, Charlie.
Roger.
Okay, we've got the flight plan out for this one. We're looking at it.
Roger. It's on the back page, Tom. On the LEM stuff, primarily, looks like the command modules side is in good shape. But on the LEM side, if you'll notice under the column, do direct return abort for loss of, we have an X beside the primary loop. We'd like to change that to both loops, that we'd have to lose both loops before we did a direct return. Over.
Okay. In other words, you said we could go at the secondary loop because you figure that things would last for a period of time?
Roger. If we went on the secondary, we would do the PDI abort sequence, but it's such a short time frame from between the DOI and the direct return that we don't think that we should go that route just for losing the primary loop, and we'd feel we'd be satisfactory coming back on a secondary loop with a PDI abort. Over.
Okay, that sounds good to us. Since we've seen some how the GNN system has worked in the altitude chamber without the coolant, we'll go along with that for sure.
Roger. These are suggestions, of course, and let y'all have time to cogitate over them, and then we'll you can come back with us if you disagree. At the bottom of the page, under the do not perform rendezvous for loss of, next to the last line, we list RCS systems, and we have just an X. We say that we would not perform the rendezvous for loss of either RCS, A or B. Over.
I think we agree with that completely. Either one.
Roger. Well, that's just slight clarification. And also, moving over under the same heading, RCS systems, for the PDI abort sequence, we recommend that we do not go to that sequence for loss of one system. In other words, if we lose one RCS system, we continue with a nominal plan. Over.
I think we ought to talk that one over.
Roger.
Well, I'll just think about it for a little while, okay?
I'm a little bit lost, Charlie. You say do not perform rendezvous for loss of either RCS system, and then you say do PDI abort sequence for loss of neither one. You continue the rendezvous or what?
After you're committed to the rendezvous, is our feeling that, in other words, once we've done DOI, that after you've committed to the rendezvous, then you would not change that sequence for a loss of an RCS system, that we would continue on nominally. And that's a trade-off. If you mean time to failure and all that stuff, when you look at it, we just think we're better off with the nominal timeline once we are committed. Over.
Yeah, we certainly like the nominal timeline, but the main thing is what you say, the mean time to failure for that other system. If we lose attitude control, we could be in trouble.
Roger. We agree, Ten. If we'll go, it's 2 hours we're talking about, of course, and we'll go either way you guys want to go. It's just this is strictly a recommendation.
Okay, let us think about it for a little while, Charlie.
Roger.
Charlie, this failure is obviously between DOI and phasing, because once you've done phasing, you're committed to the nominal anyway.
That's affirmative, Ten. We look at also that really we feel really what you're talking about is just 2 more hours of station keeping, because once you're past phasing, you got and you're down to one system, then you're on the RCS for most of the burns anyway. I shouldn't say 2 more hours of station keeping. I should say 2 more hours of attitude control.
Yeah.
I guess one reason or one question we have in mind, is what caused you to lose that one ring? What was the circumstance that caused you to lose it? And what are the chances that 2 hours is going to make a difference? And whether you do a PDI abort or whether you do the nominal.
Roger, go ahead, Tom. I cut you out. Excuse me.
Yeah, I think there's another thing. That's the time sequence. If it occurred early after a DOI, we might go ahead and PDI abort. If it occurred real late, take a real fast time. Initiation below the 30 and 40 seconds.
Ken, you're fading out. Unreadable now. We're switching antennas on you. We'll be back in a moment. Ken, Houston, we're back. Do you read me?
Okay, how do you read now, Charlie?
All right, 5 by Tom. Look, we aren't just suggesting we feel like it's more of a real-time situation here, and about what kind of failure we've had, and how much time we got, and we'd play it real time. There's certainly situations where you'd want to come back with doing the PDI abort sequence. So it was just something for you to think about, and I think it's more of a real-time situation than a hard and fast rule anyway. Over.
Yeah, that was just exactly what we were coming around to. It's awful hard to write that rule down on paper and to say like if it happened early and you could see what happened to it, you might do the PDI abort. If it happened later on where it'd be time rushed to do the PDI abort and other combining circumstances, you would probably go ahead with the nominal.
Roger, we agree.
So, I'd say just leave it up to real time.
Roger, we agree.
Okay.
100%. We're with you.
Alrighty, fine.
And Ken, it looks like more and more that the trunnion cowl is becoming less and less of a priority here, and we're recommending tentatively now that we continue the PTC on through that and get this later on, but we're checking with a few more experts on the problem. Over.
Okay, that's your decision.
Roger, we'll let you know, John.
Charlie, would you pass on the word to Christopher C. that we're saving all this fuel so we can get him some good landmark tracking?
Roger, sure will. And Tom, I talked to Faye on the telephone just a minute ago, and all's real fine at home, and they've really been enjoying your TV shows, and all 3 of the gals think they're married to a bunch of hams up there after yesterday's show, and they really enjoyed it a lot, and everything's just real fine.
Okay, thank you.
How can you be a ham when you're just trying to show that the world's round?
It's the interior shots that they were referring to, I'm sure.
Oh, were those live? Hey, Charlie, I want to talk to you a bit about the data since you were in charge of it. We've got some pretty interesting flight plan notes that were penciled and taped in at the last minute. We're wondering if you want to see some of those down there.
Roger, it's up to you guys, whatever you think. Most of this goes out live, so if you want to show it, be fine.
Well, since you did such a fine job on the data, we thought we'd, like to express our thanks.
Roger, well, I take really not much credit for that.
You might have to clear that with Gordo and Ed.
Right. Ed's sitting here right now grinning from ear to ear. Hey, we didn't think you guys were looking through this.
Grinning about another.
We didn't think you guys were.
You won't grin long, I'll bet.
All right.
Yeah, we're trying to stay ahead. We've gone away all the way through the flight plan to the end.
Right. I'm glad to see you're reviewing all that data.
Yeah, we're trying to do our homework up here, Charlie.
Right.
Ed is Ed Mitchell, the lunar module pilot on the backup crew, and Gordo, of course, is Gordon Cooper, the backup commander.
Houston, we're go with without a trunnion cal, and we'd like to stay in PTC. Over.
Okay, sounds good to us. I don't think we've had a thruster fire in a long time.
Roger.
This is Apollo Control at 50 hours 53 minutes. Apollo 10 is 169,456 nautical miles from Earth, traveling at a velocity of 3,514 feet per second. Spacecraft weight is 93,267 pounds.
Deliver.
Houston, were you trying to call 10?
Negative.
Okay. You know, for information, I guess it caught me a little bit unexpected, but even with the S-band squelch on, you know, we can hear this very fine, not annoying at all, but very fine, soft crackling in the background, but not the typical loud S-band that drives you out of your mind.
Roger. Stand by. Roger, we got this when we
pretty much.
Go ahead, Gene.
Go ahead, Charlie.
I was going to say in this end, boy, when you break lock, it really is grim. We got to get synced up on this delay here.
Yeah, I know. I can. When we cut each other out, I can hear my voice coming back to me that I said a second or two ago. But we don't. When we break lock or we're changing antennas or one thing or another with that squelch on, we can tell it, but it's very acceptable. And even right now, I've got a very low crackling in the background. Normally, on a good lock-on, I don't.
All right, I can hear that too down here in the Mocha. When we break lock, it really is loud down here, of course. We don't have our equipment turned on, and when we start getting a bad signal, it really is deafening almost.
I guess the only reason I mentioned it, I was surprised that I'd hear anything at all with that squelch on, but I do, and it's really very good because it's acceptable and yet detectable.
Roger.
Houston, Apollo 10.
Go ahead, 10.
Okay, Charlie, looks like we finally drifted out of the dead band and fired a couple of thrusters.
Right, we see you at 30 on the pitch here.
Okay, Charlie, does it look like we should go back to and start all over again or just continue on as is?
GNC says it looks good just the way it is, so we just ought to continue in, and it looks like we're coming back into the deadband now at 10, so let's just leave it like it is and watch it for a while.
Okay. It looks like, I guess we went about 20 hours out of the thruster firing. That's pretty good.
Roger, we concur. It was great.
This is Apollo Control. That thruster firing was at 51 hours, 10 minutes. The last thruster firing prior to that was at 29 hours, 53 minutes. At 51 hours, 12 minutes, Apollo 10's distance from the Earth is 170,089 miles. Its velocity is 3,501 feet per second.
Hello, Houston, Apollo 10.
Roger, go ahead, 10.
Roger, we seem to be waltzing off here against that yaw deadpan, and the thrusters are continuing to fire.
Roger, copy. Stand by. We'll look at it. We might want you to start up again. Stand by.
Okay. Houston, Apollo 10, I don't know if you can read on telemetry, but we've had about a steady stream of firing for the last 4 minutes.
Roger, 10. We are not copying your, we're in low bit rate. We're not copying your thruster firings. We notice you on the edge of the deadband. We're discussing this. Stand by.
Okay. Okay, Houston, Apollo 10 is continuing to fire about once every 4 or 5 seconds.
Roger, 10. We copy. We're stand by. Just 1 more minute.
Okay. There we go again.
10, Houston, we recommend you go to min-impulse and try to pulse it away from the edge of the deadband and then back to rate command and then us watch it. We're having a debate whether we should just stop PTC for a couple hours or not, and we're checking with the thermal people. And if you stand by. Hello, 10, Houston.
Go.
Roger, you can discontinue PTC at this time, and we recommend you select a attitude of pitch 90 and roll 307 and put us in a good TV attitude, and then you can go to just drift, and we'll watch it for you, and if you start getting out of that attitude, then we can min-impulse back. Over.
Roger, pitch 90, yaw 0, and roll 307.
That's a firm.
Okay.
Uh, 10, Houston, in this attitude, we'll have a high gain antenna and a pitch of 023, yaw of 265.
023 and 265, right.
Hey, firm, and we're going to try to come up with some stars for you for P52 and maybe a sextant correction, a trunnion cal too. We'll let you know on that.
Roger.
Okay, Houston, Apollo 10, we've maneuvered to roll 307, pitch 90 and yaw 0, and holding in that attitude.
Roger.
Houston, you want us to just turn the thrusters off now?
Stand by, we're discussing that right now, 10.
We maneuvered there in wide deadband. If we turn them off now, we'll just go all over the place, I guess.
Right, it's your choice. We'd like you to stay near this attitude, and we don't think you're going to use too much in wide deadband, so if just keep them on, and we'll be in good shape. John, it looks like you got a pretty good star for the trunnion cal. We're coming up and rechecking it for you, and you probably do your P52 in this attitude also, and we'll have some stars for you in just a minute. 10, Houston, have you got a good view of the Earth out of one of your windows? That's why we came to this attitude.
Yeah, it's a beautiful view out the left, the side window.
Roger.
Couldn't ask for any better. And we're going to change your seats around here.
Roger, Tom. And we're coming up about 9 minutes away from the wastewater dump. We're ready anytime you guys are.
Hey, Charlie?
Stand by. Yeah, go ahead, 10.
The nozzle on this bag is on the wrong end.
Roger. You're defying the laws of physics.
Yeah, we'll show it to you in a little bit.
Okay, we're standing by.
Okay, John's all set to start on his P52 here. And you want the wastewater dump first?
Nick, I think that'll run your P52. We're thinking about doing the P52 but first. I don't think there's any really big sweat on the water dump, but if you'll just stand by 2 seconds. Go ahead. You can do your P52.
Okay.
10, Houston, we should be able to get to high gain now with a pitch of 023 and a yaw of 265.
Pitch 023 and yaw 265.
Roger.
This is Apollo Control at 51 hours 44 minutes. Apollo 10's distance from the Earth is 171,171 nautical miles. Velocity is 3,479 feet per second. We'll continue to stay up live for any voice transmissions.
10, Houston, we recommend for your trunnion cal that we star number 31, Arcturus, probably require just a little bit of maneuvering. It looks like the best to us. Over.
Roger.
And 10, looks like, I think we passed on to you earlier today that we're skipping mid-course 3, and we probably will skip mid-course 4. It's in the order of 3.6 feet per second right now, and we're leaning towards skipping that one also. Without the mid-courses, we have a perigee of 60.7 nautical, and at LOI-1 we can achieve a 60 by 170. And with LOI-2 we can get a 60 circular. So looks like we're leaning towards skipping mid-course 4 also.
Okay, that sounds real good.
Roger, it looks like pretty good shooting here. Ten, we copy your torquing angles and your star angle difference.
Houston, Apollo 10, do you want us to go ahead with the calibration test at this time?
That's affirmative. We recommend star Arcturus 31.
Okay.
This is Apollo Control at 52 hours 1 minute. The flight surgeon reports that the heart rates for each of the crewmen has been averaging in the lower 60s throughout the day.
Houston, Apollo 10, are you copying verbal 6987 there with us?
Roger, we stand by. We copy it. Houston, we're satisfied with the trunnion calibration. It's looking good to us. You needn't do any more.
This is Apollo Control.
I believe that 89992 is probably the best number. These are right on the edge of the section. It's about to disappear out of it.
Roger, 10, we copy. It's looking good to us. You can discontinue that. We have a load at the site for you, and if you give us 2 and accept, we'll send you a state vector.
Roger, I'll load the 89992.
Roger, we copy.
At 52 hours 5 minutes, Apollo 10's distance is 171,898 nautical miles, velocity 3,464 feet per second.
Houston, Apollo 10, when do you want our water dump?
10, we're through with your update. You can go back to block, and we are debating now on the dump. We got to get all the cameras configured. They want to try to photograph this again. We're looking probably at 5215, but we'll have an exact figure in just a minute.
Okay.
Houston, this is 10.
Go 10.
The reason for the delay between the start to T-52 and initiating it was when I went to look at the sextant, the eyepiece had floated off, and so we spent about 2 minutes scrambling around in here, and it was over behind Gene's sleeping bag, if you can believe that. Now it got there, I don't know. It couldn't have been off more in about 3 minutes.
All right. You can sleep with it in your pocket tonight.
Yeah, we're taping it on, but that's the kind of thing I would think that ought to be sort of held in place by something better than tape.
Roger. We agree.
I think they have to do Dave on
9-2.
Gotcha.
That's John Young with that report.
Uh, 10, Houston, you can proceed with the dump at 5215, over.
Roger, 5215.
Uh, 10, Houston, I'd like to give you a GET time hack. We're coming up on 5213, and it'll be on my mark, 5213. 10, Houston, mark, 5213.
Roger, we are synced.
Right.
Did you allow for the speed of light there, Charlie?
Yes, sir. I got it 1 second early, so you should have had it.
Okay.
Me and the retro can really count
Roger,
here.
another second ago. Taking lots of lessons from Llewellyn there, huh?
Roger.
Okay, I've got the CNC clock going. It looks synced here.
Roger.
Apollo 10 is far enough out now that there's a 1 second delay in transmissions between the control center and the spacecraft, and vice versa.
Here comes the water dump. Houston, we're dumping.
Roger, copy.
Houston, Apollo 10, has any of the telescopes been able to see the water dump yet?
We haven't got word back on that yet, 10. It'll probably be a while before they get their plates and things developed. I think they're taking pictures of everything, and it takes them a while to get all that information back, and so far we haven't heard where they've been able to see it yet or not. We'll keep trying to find out that word for you and let you know.
Alrighty.
This is Apollo Control at 52 hours 21 minutes. Red Rover, who was most recently associated with Spider and Gumdrop, is in the control center now, monitoring the activities of Charlie Brown and Snoopy. Red Rover is also known as Rusty Schweikart, the lunar module pilot on Apollo 9. Apollo 10 is 172,421 nautical miles from Earth, traveling at a velocity of 3,453 feet per second.
Houston, Apollo 10, did you transfer the CSM state vector to the limb slot, or do you want us to?
That's affirmative. We sure did.
Okay, I didn't catch it till last.
Roger. Uh, 10, Houston, you can stop your dump now.
Okay.
This is Apollo Control. The quantity of wastewater dumped was 9.5 pounds.
Apollo 10, Houston, John, we noticed after your trunnion bias check, when you entered the 89992, that we saw a flashing 59 come up instead of the 92, and we don't think that number got in. It's not any big deal, but whatever the number is okay, but we don't think it went in, what you were trying to load.
think. Can you see that, Charlie, or you guys got email?
Roger, we see those. We see your register. It looked like to us that instead of the proceed, you did a verb 32, and we saw the 59 down here when you entered that entered that number, John. Stand by on this display.
No, I just called up 687. Didn't the second register 89, whatever it was supposed to be?
Stand by. That's what it's supposed to be. I'm not sure. Hold on a minute. Let me talk to the guidance guys.
Oh, please don't tell me it's not in there.
Ken, that location 87 is time shared, and those numbers that we're looking at are result of marked data. The 89 and 99 2, we don't care whether it's in or not. The point was that instead to incorporate that, when you entered it, it appeared to us that a verb 32 was done instead of a pro to incorporate, because we saw a 59 display instead of an 0692.
Right. Oh, yeah, okay.
And that's really all we were trying to say, John.
Okay, yeah, I know that. Well, that's why I loaded it in there.
All right.
And the next time we do one, if I don't get a chance to do it Trunnion Cal, I'll load that number.
Okay, fine. That's great.